Hi, I'm pushing to get a PCB order together. What I want to include are the control ROM PCBs, the control ROM control PCB, and its backplane or possibly a midplane. Not sure exactly how I want to handle that. I've got a decision to make there. Today's video is a push towards getting to that point. So I want to tackle the control ROM control PCB layout, and then I've got some additional work to do related to the control logic, schematic, and PCB. So this video is actually a heavy lift. Let's get started.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
Okay, the first item I want to try to tackle today is the control ROM control PCB. Now here is the schematic, and up here I've got some parts that are not fit, and that is because I may be able to fit this with an oscillating crystal and then remove this 0 ohm resistor and populate this 0 ohm resistor and change where my raw copy clock source comes from. So one of the things I want to take a look at here is when I build this out, I may have a crystal that I populate, or I may take the raw copy clock off the clock module, the raw system clock off the clock module, and determine which one of those actually become the copy clock. I'm not exactly sure quite yet how that's going to work, but once I actually get the PCB in my hands and I can see what its behavior is different than the breadboard's, I can make a decision on that at that point. The other thing is that I expect this fully to be a two-sided PCB. I have a limited width, and that is the width of 2 of the control ROM modules themselves, plus 1/10 of an inch in between them just for spacing purposes. And so I want to have this control ROM control module span the entire width of both of those. Now I could go to 3 wide. Not sure if that's going to work out or not, but whatever I put on the underside of that PCB is going to be very difficult to test. So I expect I'm going to have to start adding in some test points into this schematic as I get into the PCB design, and that's going to make it a little interesting because I've not done that yet. So let me roll up my sleeves and get into this. I'll start placing some of these components, and we'll see how this goes. I probably have to take a look at footprints first before I even get into that. Okay, as I go through the footprints, I realize I have to double check to make sure that I'm selecting the correct one for the ICs that I'm using. The first thing I want to do is I want to try to get the edge cuts placed. Okay, that's at least the width that I need to fit this in. Now I've got to figure out how exactly I'm going to do that. I start by trying to sort through all the different components and put like components together into little submodules, little groupings, if you will. The easiest of those are the LEDs and their resistors and the line drivers associated with those. What's fussy here is trying to track which signals go to which locations and keep track of them on one side of the board or the other. And then, of course, reduce the size of the PCB as much as possible. I'm missing a capacitor. Okay, well, all the components fit. The question is now, can I get them lined up right and route them? That's going to be a bit of a challenge. I do have a bit of room down here on the bottom. KU11 is spun around the wrong direction here. Let's fix that. Okay, I've got to flip the power connectors down onto the bottom of the board. I'd love to get some text in here. I think I can move these up a little bit to give me a little bit more room to route. Let's see what that rat's nest looks like here. I then spend a good bit of time investigating all the signals to see if there's anything that looks exceptionally difficult to route. I move some of the ICs around a little bit just to see if I can make some more room for some of the more congested areas. Ultimately, I decide it's not going to work, so I spend some time reorganizing the layout. Okay, I think this is going to be quite tight. I believe that I'm going to have a lot of trouble in this area up here, trying to get everything routed. The good news is I have the ability to expand the PCB height-wise, and so if I need to, I will. But what I've tried to do is make sure that each of these signals over here on this side remain on this side and don't have to come back across the board. Most of these are going to stay over here. So if I start over here and look at this, I'm kind of jumping from one side to another. And this should hopefully allow me to get most of this wired up relatively easily. And then down here, I've got different LEDs that are being driven from these line drivers. What I haven't looked at yet, and I will do that in a little bit, is what signals are exclusively on the back so that I have no ability to test them on the front. And so I will end up putting some test points in order to accommodate that. And I'm likely to stretch some of this stuff out just a little bit to give me a little bit more room. But let me start wiring things up. I'll start on the right hand side and get all that done because that's going to dictate what I can do from the left hand side over into the right hand side. Let me argue with this a little bit. Well, I end up spending about 90 minutes working on this before I realize that I've made some pretty significant errors, and I end up deleting all the traces and starting over. I'm not going to make you sit through that. This has ended up being just a little bit dense for me, so I am trying to create a little bit of extra room to see if I can't get things lined up a little bit better. To do this, I deleted all the tracks, and I'm literally starting over with no tracks, no traces drawn. So let's try this again. Okay, a good bit of this overlaps nicely. What do I mean by that? If you keep an eye on these two pads right here, both of those are VCC, and VCC is on the back. So I can literally drop a via right between them and make sure everything's connected on all sides, and that's well taken care of at that point. And I do have issues like this down here where I've got ground reference over a signal and ground reference over a signal, but I can get through that. That's not the end of the world. Similarly here, I've got VCC sitting over a VCC pad, and same thing here, so I can literally drop the vias right where I need them to be. The hardest part I've realized is the interconnects between these two rows of ICs. So for example, this signal needs to come down here, that signal needs to come down here, and of course they need to cross. That signal needs to come over there, and that signal needs to come over there, and of course they need to cross. So I've got a little bit to work through here. The other side of this is there are signals from here, and they'll be down here. That needs to make its way up over here. This needs to make its way up over here. Now I've got a lot of space in between the rows of pins here for the line drivers that I could take advantage of. So I do believe, I'll be pulling a lot of signals down this direction and then over along this way. We'll have to see how that all works out. I may have to make some room over here for some of that stuff. As a matter of fact, let me do that now. That should give me room on this side, on the back side, to bring those signals down and then over. I'm going to work on trying to get things hooked up in between these two rows, and I'm going to start with that and just see how things work out here. Alright, let's drop some vias and some power traces in. This ended up being quite fussy. In the end, I ended up hiding all the layers except for the copper layers on top and bottom, just so that I could focus my attention more on how I was going to route those signals than all the rest of the stuff around it. Well, I'm not sure what happened, but I lost some video. But I do have the right-hand side of this PCB wired up. I'm not going to say that it looks fantastic. It's not the most elegant wiring job that I've done, but it is done and everything fits on the right-hand side. Fits meaning I don't have any major issues. Above and beyond that, I actually have some room to put some text, so that's good. All the signals that are required have been pulled out to the left-hand side of the board, except for VCC and ground. Both of those need to be pulled over. But I've got tons of room over here to get this wired up, so this should be relatively simple to accomplish. Okay, I have 2 unused gates here. And what I want to do is I want to be able to bodge my way into those if I need to. So I'm going to go back to the schematic and put in some 0 ohm resistors so that if I want to, I can bodge my way into that and have a couple of extra AND gates. Next, I start working on hooking up the rest of the stuff on the left-hand side. I'm a little bit all over the place, and I think I end up paying for this a little bit in the end, trying to route some of these signals. Let me see what I can do with the 74HC165 shift register. And my concern here is making sure that I have the ability to probe these signals. Now I am on the opposite side of the board, so the back of the board is actually facing up. I think I'm going to stick that there. Okay, all of my VCCs line up pretty nicely here, but I've got a lot of grounds that I need to connect. Now these are all signal grounds, not power grounds, so those should be relatively easy to get connected. This is the one that I need to pull a pad out for. And my done thing here is not going to be in a good spot. Now it's time to set up that test point. I want to bring the command address signal from the shift register up onto the front of the board. Okay, then it's just the final push to get the rest of everything routed. It's not the best job I've done. I ended up having to get a little creative as I'm going through trying to route some of these signals, but it did eventually all fit. Okay, let me jump ahead to where I'm looking for the final traces to actually route. For those final traces, they can be kind of difficult to find. What I find it easiest to do is to actually hide every layer, and then those missing traces actually stand out because they're the only thing left on the screen. Okay, that's everything routed. Let me drop in some backplanes or fill, I should say, and then I will start with the rules check, and then we'll move on to the Silkscreen. Okay, let's get the electrical issues sorted, and then I'll start on the Silkscreen. Okay, that gets all my copper addressed. Now let's deal with the Silkscreen. Okay, I've got the front side of the PCB whittled down to the silkscreen and the courtyard. That way I can take a look at things and get things organized a little bit better. I'll start with the LEDs. Okay, I just checked my supplier's capabilities and I'm setting this to be less than what they're capable of. Okay, those locations that I inserted the 0 ohm resistors for bodging in additional gates if I needed them, they're a little too dense to label them directly, so I have to come up with a method to get them labeled that is readable. Okay, I'm going to remove this test point. It is actually not required because I have access to it in the pin header. Okay, let's check my work so far. Taking care of the back silk screen is very much the same as doing the front silk screen. I'll run through this really quick. And finally, the last bit of cleanup. Okay, that was a lot of fuss, but I'm glad to have that done. It's going to be a dense board. My biggest challenge at this point is being able to get the soldering iron in between the ICs in order to make sure that they're soldered down properly. It'll be fun to hand solder this. Okay, Adam, what did you forget? Well, one of the things that as I go through assembling is I'm going to need to be able to know where to place each component. And for that, let's see here, I want the courtyard. For that, I do not have anything that labels. This is a 74HC74, and that's therefore the component that I really need to put in there. So I need to go back through one more time, and then for every IC location, I need to place a label saying what the IC is that needs to be placed there. I'm not going to do this with the crystal. That's relatively obvious. The rest of it, though, do need to have something called out. Okay, one more rules check here just to make sure I'm not doing anything silly. Very good. The next task today is going to be to aggregate the control ROM control and each of the control ROMs themselves onto a midplane. That midplane is going to be responsible also for demultiplexing many of these signals and passing them on off to the backplane. And so the first order of business is to take care of that in the emulator. So once again, this is likely going to be a pretty significant change. I'm going to work on that, see how far I can get that done. But ultimately, things are going to come out of the computer module and then into the midplane module, where then the computer module itself is going to be reduced down, at least for these components, into the midplane. I'm likely to do the same thing for a register midplane and a ALU midplane, ultimately ordering one large scale backplane on which I can install everything. All right, let me get into that. Well, I will say copy and paste and multi-line editing are certainly my friend. It didn't take nearly as long as I thought it would take to get this all pulled together. I've got the control ROM control, which is going to sit on this midplane, each of the control ROM modules themselves, which will sit on this midplane. And then also on the midplane are going to be the demultiplexers that are going to take several of these signals and break them down into individual active high signals. There are several buses which are involved on the control ROM control and need to get access out onto the backplane. Really, they're passing through the midplane, and rather than implementing the bus in the midplane, it's better to just provide pass-through from the individual module out onto the backplane and let the backplane handle that. So several of these are listed out here with the intention of never actually having them integrated into the midplane, but I am calling them out just to make sure that they don't get lost. I know for myself, if I don't document it, I'm going to forget about it. There are really 3 inputs to the midplane which get passed on to the individual modules it supports, and then a ridiculous number of signals that can come off of the individual modules and then out onto the backplane. Some of them are directly issued, so the first 4 signals there are directly issued and just passed through. The remaining signals here are actually passed through a demultiplexer. But then when I get to the actual code itself, there's a lot of copy and paste that went on here. And so I do have something to solve here, and that is the raw system clock and how I'm going to deal with that. The wire up is really the large part of this, where I have to wire up all the different control ROMs, and I created a little subroutine to help me with that so I don't have 16 copies of the same stuff. But then I had to go ROM by ROM and take the output signals, decide which ones needed to go to the respective demultiplexers, hook those up, and then everything for each ROM that each ROM controls had to be published and signaled out on the different signal procedures. There's a lot that went into this. So what's next, Adam? It compiles, but I have not tried to execute it yet. The first 2 things I need to try to accomplish are getting it to copy data from the ROM to the SRAM. And that's going to be both with the rapid copy or the quick copy and the pedantic 32,000 clock cycle copy that needs to take place. Both of those have to work properly again before I can move forward, and I've got a little bit of cleanup that I have to do in the computer module so that I don't have a bunch of commented code. So let's try this once just to see what happens. Nothing. Not even a check of the integrity. So yeah, there's some stuff to fix. Let me get into some debugging. Alright, the first task I want to take on in the debug is making sure that I get the pedantic copy working. If I can't get that working, then there's bigger issues to deal with, so that becomes the foundation for everything. Let me work on this. If I discover something new, I'll come back and let you know what I find. If not, next time you see me, it'll be to show you that the pedantic copy is working. Well, okay, that really didn't take long at all. I went to look for the copy clock and realized the copy clock doesn't exist. And then I realized the control ROMs don't exist. So I guess the first order of business is to make sure I've got all the components showing up on the emulator. Okay, I'm getting these runtime errors. Signal not found in control ROM module. And my error is, and I made a change to this line, that I actually have the signals and slots backwards in my connect. So quick change here and I should be on to the next issue. Okay, I've got the control ROMs now showing up and the control ROM control, but there's no clock. So that's next up. Okay, I've got the copy running. This is the pedantic copy. We'll wait until the end and see if it actually checks out. While this is running, I'm not seeing write enable ever come active, so I don't have a whole lot of hope that this is actually going to work properly. Well, it never did the sanity check. Well, that looks reasonable. Looks like I might have gotten 16. I think what I need to do is change that so that each control ROM has a name and I output the name as part of the sanity check. I'll be right back with that. Okay, let's see how we did. And I'm seeing 0 through F, so that's good. Okay. So I put a little bit of debugging code in just to make sure that I was actually getting the write enable signal, and you can see that I'm actually getting those being output to the screen. So that takes care of that concern. Okay, switching gears to the quick copy. Let's see how that turned out. And once again, it looks like everything matches. I did clean up the comments. I have not done anything yet with that system clock. And with everything working the way that it is, I'm not sure that I need to do anything with that yet. So what I'm going to do is I'm actually going to comment this to keep it there, but leave it commented out so that I can come back around to it if I feel I need to. Now, with all of that done and looking at my objectives for this video, I'm afraid that if I start the schematic, it's going to take the video to be longer than an hour once everything's done. I'm not quite ready to call it here yet, so I'm wondering what else I might be able to work on. And it occurs to me that even though I don't have memory, and I don't have a fetch register, and I don't have an instruction register, I probably should be able to free run this and execute nothing but no ops. How would that happen? Well, no matter what the program counter address actually is, if I serve up a no op into the instruction bus and feed that into the control ROM control, it should be able to do the lookup for the no op and execute the instructions for that. Now, how would that happen? That would happen based on pull down resistors that were placed into the instruction bus, and I've got that. So all I really need to do is perform the hookups necessary for the program counter to increment. That's the only signal that would be active, and I should be able to free run. Let's see if we can make that work. So here's the code I added. Well, that didn't quite work out. I guess I've got some debugging to do. So nothing is asserting on address 1, which is not a problem. It should be asserting out onto address 1, so I do need to get that fixed. And my increment is not happening. So that's the one I did hook up, and it's not taking place either. So what could be the problem? Well, I'm going to have to throw some debug code in to try to figure that out. Well, that's not good. But then again, that's why it's there. I switched back to a pedantic copy. I figured it was easier to get that working. Well, I found a segmentation fault. Put some debugging code in around this and found that one of my outputs out onto the bus is actually causing loops. I believe it's related to the SRAM because it's the only thing that has bidirectional pins. So let me see if I can figure that out. Well, I did manage to get the segmentation fault dealt with. To do that, I actually had to nearly completely rewrite the interfaces for the SRAM. But I'm still not yet getting any output off the SRAM, so there's still something wrong that needs to be solved here. So I will continue digging. Okay, still in pedantic mode. The control ROM is no longer being corrupted. I am obviously counting now. You can see the program counter in the upper left counting and asserting out onto address bus 1. So that's good. What is not good is the contents of the control ROMs over on the right hand side are not actually displaying the contents that they should be displaying. They are still showing the last value that was loaded during the copy. So I need to get to the bottom of that, and then I believe I should be able to give the quick copy a try and see where I stand with that. Well, let me dig a little bit more and I'll come back and report what those results are. Well, I switched over to a quick copy in an effort to see if I could improve the time it takes to execute a test, because that copy does take quite a bit of time. And I'm not getting the same behavior. And it looks like it may be because all of the lines are being asserted through the control ROM. That last value is never being updated properly. So what I'm going to do is I'm going to switch back to the pedantic copy, but I'm going to wire up something else into a different register just to see if it is that data. Now what I'm going to do is I'm going to take one of the unused bits and do that wire. And then we'll see what that does. I have a feeling that it's the fact that everything was left on that's now the problem, not the fact that I actually got it working. Okay, so I took off of control ROM 5 the most significant bit, which is completely unused, and you can see that the increment signal in R1 is now being asserted. I didn't connect the clock, so it's not actually counting anything. So ultimately what it boils down to is I am not actually passing on these values to the control ROMs where they can actually perform the lookup. So I need to get into that and figure out where that problem is. Well, after a hard night of debugging, I finally have the increment working. You can see control ROM 7 is now asserting the increment signal properly. What was the problem, Adam? Well, the problem was I had that line wrong. I was actually shifting to the left 6 bits instead of 7, and therefore I was not actually ever getting the right bit into the right place. So that solved. I am actually counting now and not doing anything, but it's executing properly, no ops. Now I have this in quick copy mode. I want to redo this in pedantic mode and make sure that everything's good here. I no longer have the SRAM being overwritten, and that was a problem with how I was performing the reset. I was resetting the write enable last. It needs to be reset first. So that was a quick fix once I identified that. All right, let me rebuild this for a pedantic copy, and we'll give that a shot and see how that works. And this is working as well. Nice. Well, I can't even begin to tell you how thrilled I am to have the emulator actually executing code, even if it is just no ops that are hard-coded without any memory to back it up. We'll change that at some point here in the future, relatively soon. But before I get to that, what I really want to do is get that control ROM midplane built out in schematic, and then turn around and build that onto PCB. It's not going to be an inexpensive piece of PCB to order, but I do want to get it ordered relatively quickly because ultimately the goal is going to be to use the midplane as a temporary backplane. And then when I do order the final backplane for the entire computer, I will just flip the connectors around and drop that straight into the backplane. Anyway, next video I am going to get into that, and it's likely going to be a good KiCad session, and if I have some remaining time I will get deeper into the emulator. We'll see you soon.